Welcome everyone to another interesting DSA problem which is titled as Palindrome Linked List. So as you already know, what is a palindrome? Palindrome number or palindrome things. So basically, if 1 2 1, if you start from this left side and go to the right side, or also start from the right side and go through the left side, both of them is giving you the same number. So that is mean by the palindrome number. In the linked list, as you move forward, if that particular number, okay, if it's get reversed also, then both of them should give you the same number. Then it's a palindrome linked list. How can we do that? So one of the ways we can do is that either one thing you can do is that you can store it in an array, like as you traverse through this linked list, you can store these numbers in a linked list and you can accumulate and just reverse it, and you can have a simple check whether the reversed thing is equal to the normal one. If that's the case, then you can return true, that is palindrome, and if that's not the case, it's false, it's not a palindrome linked list. So that's a straightforward thing. But if you are utilizing an extra array or list to save that information, the space complexity would be going of order of n, and while iterating it would be order of n. So can we make it a bit better? Yes, we can make it a better. There is an optimum way we can do this thing. What we can do is that we need to identify the middle node. Here this would be the middle thing. Then what we can do, whatever we followed by this middle node, okay, we can just return all the pointers. For example, if the last pointer is like leading towards none, what we can do, we can convert something like this 2 would be like return to none, and this 1 would be returning like pointing to the 2, like that. If we are able to make it, then what we can do, we can fix a pointer here as left and fix another pointer here as right, and we can check the value of left dot value and right dot value, and we can just move forward by simply left dot next and right dot next. So before moving forward, I would have also wrote the class list definition and all those things, so this would be pretty much handy. I'm just copying from one of the previous problems. Okay, so let's write it here, so you will understand what I'm going to do exactly in the following steps. So let's write class solution, define is palindrome is the method name, self head is given, which is nothing but just an optional list node, and you are supposed to return a boolean expression, true or false, based on checking the first one. So to find out the middle node, we are going to use the slow and fast technique. Slow, fast, initially assigned as head, then fast will move 2 steps and slow will move 1 step, while fast and fast dot next, slow equals slow dot next, fast equals fast dot next dot next. So this will make us reach to the middle point, and now from the middle point, whatever is going to follow following node, we need to reverse it. That's why we are going to do it. So initially let's fix previous equal to none, and we can use another thing, while slow is in the middle. Okay, we can access the next node by simply calling slow dot next and the pointer of the next node, or the slow dot next, should be pointing to the previous. Here it is none, and the previous should be assigned as slow. So what is happening here? So we are at the middle. Whatever will be the slow dot next in this example, this is slow dot next. Okay, we are saved it as next node. Okay, and the slow dot next, nothing but here slow dot next would be assigned by previous, that is nothing but none. So basically this is not the middle. Actually in this problem, if we calculate, if we follow finding the middle, we will be reaching somewhere here. Okay, the slow dot next, whatever the next, this arrow key, this particular arrow now will point towards none, that is previous, and the previous would go to none, and the previous would go towards the slow right now here. And then what we need to do is that we need to update the slow equals next node. So this is a subtle arrangement. You should check it with example. For example, right now it is here. Okay, right now it is here. So next node is nothing but slow dot next. Next node is 1. Okay, and slow dot next is previous, that is nothing but none, and previous is equal to slow, previous becomes this thing, and slow equals next node, and this slow jumps here. Okay, and it will keep on coming and it reverses, and once it's reversed, this will become something like this. Then we need to check. Let's assign left comma right equals head comma previous. So while right, what we can do, if left dot value not equal to right dot value, that means it is not going to be palindrome, then it just return false. If it's not that case, but we should advance and check everything. So there is something known as left dot next, we should advance. For example, left is advancing like this and right is advancing like this. So both will converges like this. Okay, and I don't have space here. Okay, I'm just not going to use extra page or something like that. What I'm going to do is that let me write it here. Okay, I hope you understood everything. Right equals right dot next, and at the end, once this for loop is done, okay, we need to return true. So what is the time complexity of this particular approach? The time complexity, since we are iterating through it, the entire linked list, that would be order of n. Space complexity, we are not utilizing an extra array such that later point we are going to reverse or something like that. We are not doing that, so it's order of 1. So this is the optimal way, optimal solution, and I hope you understood the problem and the solution for this particular thing. Basically, we identified the middle node, then whatever followed from the middle node, we just reversed it, then we checked it from the both ends, and that's how we have validated whether the given linked list is palindrome or not. I hope you understood. Thank you for listening.